Hello everyone! Today we are going to learn something fascinating, which is how to think like a computer. If you have ever wondered how to write a good and correct algorithm, the answer lies in training your brain to approach problems the same way a computer does. That means learning to think like a computer. By doing so, you will develop a structured and logical mindset which will make solving any problem much easier. So, let's get started. The first thing is that you need to structure your thoughts around two key components: inputs and outputs. Think of inputs as asking yourself what data is provided to solve the problem. Keep in mind that computers need clear and specific data to begin any task. The output involves asking yourself what are the results required after solving the problem. After processing the information, the computer generates an output. This output is the final result which you must define before starting to solve the problem. So, whenever you face a problem, focus first on identifying the inputs and determining the expected outputs. And this is the foundational step in solving any problem. Computers are all about following precise and step-by-step instructions. They don't skip steps or infer meaning. So, when you are thinking like a computer, be sequential. This means defining the exact order of operations. Imagine you are following a set of instructions to build a piece of furniture. You need to follow each step in the correct order to make it correctly. Similarly, computers follow a defined sequence. The second point is to avoid ambiguity. This means every step should be clear and unambiguous. Ambiguity can lead to mistakes, so when giving instructions, make sure they are crystal clear and leave no room for interpretation, because computers don't have the ability to guess missing information or steps. So, to tell the computer what to do, you have to be sequential by defining each step in the correct order, because computers execute tasks strictly in the order provided. If there is an error in the sequence, the computer will not recognize or correct it. And also, your instructions have to be clear. Don't skip any steps or leave out information. Computers cannot fill in gaps themselves. So, overall, notice that there is no place for interpretation here. The computer follows steps exactly as they are written. The third point to keep in mind is that computers rely on logic to make decisions. To think like a computer, you need to practice breaking decisions into logical conditions. So what does this mean? To think like a computer, we need to train our brains to break problems into small logic steps. Because computers use conditional statements to decide what action to take. So, you tell the computer, if the condition is true, then do this. This is like making a decision based on a condition. This part means you check if a specific condition is true. If the condition is met, the algorithm will execute a specific action. Think of this as a decision point. If this happens, do the following. Else, do that. This is the alternative action if the condition is not met. If the condition is not true, the computer will skip the first action and instead perform an alternative action. This ensures there is a default behavior if the condition doesn't apply. Hence, when you think in terms of logical conditions, you start to anticipate every possible scenario, just like a computer does. Computers are great at repetition, and so should you be. Whenever a task involves repeating the same action, think in terms of loops and ask yourself, what needs to be repeated? And how many times should it repeat? And what condition will stop the repetition? So you have to identify the action or task that needs to be done multiple times and determine how many times you need to repeat the task. And also don't forget to set a condition that will end the repetition. This kind of structured and repetitive thinking is a core part of how computers process tasks. Edge cases are unusual situations where an algorithm is tested with unexpected inputs. For example, entering a negative age. Testing these cases helps ensure the algorithm works properly in all situations. So, to think like a computer, always ask, what if the input is empty? Plan for scenarios where there might be no data and tell the computer what to do in such cases. Also, ask, what if the input is too large? Consider how to handle situations where more data is received than expected. You need to find a solution for this and explicitly instruct the computer. And of course, it's important to ask, what if the input is invalid? In this case, think about how to manage incorrect or unexpected data. Your computer will crash if you don't handle these edge cases. So, you need to think ahead and create rules that specify how the computer should act in these situations. Now, let's talk about what to do if your algorithm doesn't work. In this case, you also need to think like a computer. When computers encounter errors, they don't panic. They systematically trace their steps to find the issue. You should do the same. To debug your thinking, start at the first step and work through each one logically. Begin from the start and carefully check each step, just like you're tracing your path to find a lost item. Then, check if the output at each step matches your expectations. Compare the result of each step with what you expected. If something seems off, there is likely a mistake. If something seems off, go back and fix it before moving forward. If you found an error, correct it before continuing. This is like fixing a mistake in a receipt before moving on to the next step. To sum up, debugging is all about retracing your steps one by one to find the exact moment something went wrong. And this process is essential for solving problems effectively. So, overall, thinking like a computer involves approaching problems with structure, logic, and precision by focusing on clear input and output, following a sequential process, using logical conditions, embarrassing repetition, and accounting for edge cases, you can develop efficient algorithms. And when errors arise, debugging your thinking systematically ensures that you can identify and correct mistakes. With practice, this mindset will enhance your problem-solving abilities and help you craft algorithms. So, in the next video, we will explore a series of problems where we will apply these strategies in action.